Hello, ladies and gentlemen. Today's topic is simplifying radicals, and I'm going to try and talk a little louder because I had some concerns that I wasn't talking loudly enough. So hopefully this does it for you. On the next blank page in your notebook, write the heading simplifying radicals and go ahead and write down the objective. I can simplify square roots, including those with variables, by using prime factorization. When you hear the word or see the word radicals, okay, radical is just any number that's under a root. So the square root of 37, that's a radical. The square root of 4x squared, that's a radical. It's under a square root. So don't let the vocabulary freak you out. We're going to go through it and it's going to make a lot of sense to you. I actually think doing this kind of thing is a lot of fun, and I think some of you will too. Okay, so once you have that written down, let's talk about the steps to take to actually simplify a radical. Write all three of these steps down, and they're not going to make a lot of sense right now, but as we work through an example, they'll make more sense. Step one is to break down the number under the square root sign into its prime factors. A prime number, if you have forgotten what that is a number that can only be divided by 1 and itself. For example, 3 is a prime number. I can only divide 3 by 1 and 3. 6 is not a prime factor because 6 can be divided by 2 and 3. Okay, so you're going to break down the number under the square root sign or the number under the radical into its prime factors. And then you're going to look for pairs of prime factors that you're then going to pull out of the radical sign. And I'll show you how to do that in just a minute. Then you're going to, if you have any prime factors left under the square root sign, you're going to multiply them back together and they stay there under the square root sign. Get that all written down. I know it probably doesn't make sense. It will as soon as I go through this example. If I take, well, you still have room. Yeah, you'll still have, ooh. Let's go to the next page, okay? I don't want to make you guys write too tiny. So on the next page, put the heading example, page number, date, all that good stuff. And the example we're going to work through is the square root of 72. Our first step is to break down the number under the square root sign into its prime factors. I like to do this using a factor tree. I think you've probably heard that term before, but it's just an easy way to break 72 down. I ask myself first, okay, what can 72 be divided by? I know it's even, so it can certainly be divided by 2, and I have 36 left over. What I'm looking for when I'm making this prime factorization factor tree is I want to end up with prime numbers. I have 2 right here, and 2 is a prime number. But 36 isn't a prime number, so I need to break that down, and I know that 36 is 6 times 6. But neither 6 or 6 are prime factors. So I'm going to have to break them down even more, and each six gets broken down into a 3 and a 2. And 3 is a prime factor, 2 is a prime factor, 3 is a prime factor, 2 is a prime factor. So I have continued breaking my number down and circling my prime factors as I go because that means it's the end of a branch. Okay, that's why it's called a factor tree. If I take this and I flip it upside down, it looks like a tree um, with branches and such. So I keep going, I keep branching off until I end up with nothing but prime factors. And then my prime factorization of 72, right here, I have it. It's 2, this 2 right here, times this 3, times that 2, times this 3, times this 2. So I have 2 times 3 times 2 times 3 times 2. That's the prime factorization of 72. And that is all part of step 1, breaking down the number under the square root sign into its prime factors. After I do that, step number 2 says to find pairs of prime factors that I'm going to pull out of the radical. So I have step 2 started up here. You can continue this on the same page. And I'm going to start by reorganizing my numbers under my square root sign, under the radical. And I can do this because of the lovely commutative property of multiplication. I told you those properties were going to come up again and again. Commutative property, commute, commuter, commuters drive back and forth from, say, home to work or work to home. So you can move numbers around in the commutative property. So I reorganized them so that it's now 2 times 2 times 2 times 3 times 3. When I'm looking for pairs of prime factors to pull out, I want to get two numbers that are the same. So here I have 2 and I have a 2 here. Okay? When I pull those 2's out of the square root sign, I end up with 1, 2 on the outside. And a lot of people get confused by that. They try and put 2 times 2 on the outside. But if I were to kind of break up this square root, and if I just had the square root of 2 times 2, that's the square root of 4, isn't it? And we know that the square root of 4 is 2. So that's why when I pulled two 2's out from under the radical sign, from under the square root sign, I'm left with 1, 2 on the outside, because the square root of 2 times 2 is 2. Okay? You'll get the hang of it, I promise. So I've pulled one of my 2's out, and on the inside I still have 2 times 3 times 3. All right, now I'm going to keep on looking for factor pairs. I look until I can't find any more. And I have another factor pair here. I've got a 3 and a 3. If I pull my 3's out of my square root sign, I am left with 2 times 3. Now, the two 3's come out of the square root sign and become 1, 3, just the way the two 2's came out and became 1, 2. Are you with me so far? If not, you might want to rewatch before you move on. So on the inside, I'm left with simply the number 2, and on the outside, I have 2 times 3. Let's take a look at what step 3 says. Step 3 says to multiply any remaining prime factors that are under the radical. But I think I need to add something to step 3 in order to really finish this off. Also, multiply the factors that you pulled out of the radical. Go ahead and add that in your notes to step 3. And I'll show you what that means. Pause it if you need time to write that down. But notice how I have here on the outside of my radical sign, I have, oh, that yellow doesn't show up at all on green. Neither does that. Maybe pink? Okay, never mind. I'll just underline it. Okay, I have a 2 and a 3 out here in front of the square root sign. I'm going to multiply those numbers together. That's going to give me 6. And there's no numbers to multiply together under my radical. There's nothing left except just plain old 2. So my answer for the square root of 72, and this is an exact answer, is 6 times the square root of 2. And that is as simple as you need to make it. You're done there. Okay? Why don't you go ahead and try a couple on your own? Pause the video, see if you can work them out. Maybe rewatch the part where I showed you how to do the example. And then I'll show you the answers to these two numbers. So I'm going to pause, or you should pause the video within the next 5, 4, 3, 2, 1, 0 seconds. Pause the video. Okay, ladies and gentlemen, I have circled the final answer in blue. Okay, and take a minute. You might want to pause the video again. Take a minute to really look at each step I did. I laid out the prime factorization for you. I showed you how I put that back under the radical, how I pulled out numbers and had numbers left inside. This second one is clearly more complicated. There's more steps to it. If you didn't end up with 4 square root 5, you need to really look at what I did and see if you can figure it out. These arrows that I put in kind of show you where these two 2's go and what they become when you pull them out of the radical. And then here, these two 2's become that 2, and you still have this 2 from over there. There's a lot of 2's. I know it can get confusing. keep working at it, and we'll do lots of practice on these questions in class tomorrow. Okay, now one more topic that I want to talk about, and this is where it gets really fun and really cool. I love this part of math. When we start throwing in variables and when we start dealing with algebra. So if I have the square root of x cubed y squared, I'm going to use the same process. Oh, I forgot to say this should be on the next blank page in your notebook. Okay, so I have the square root of x cubed y squared. I'm going to break that down just like we talked about in step 1, break down the number, except now it's variables, under the square root sign. So my x cubed becomes x times x times x, and my y squared becomes y times y. Now it's just the exact same thing, and it's so neat because you can do it with letters. So if I take this, I'm looking for pairs of variables. So there I have two x's. If I pull those out of the variable, I'm going to end up with one x left on the outside. Hang on. And what's left on the inside? Well, I have an x, a y, and a y. And all of those are being multiplied together. Okay, but I'm not done because I still have a pair of variables on the inside. And that pair of variables that I have are my pair of y's. So I found another pair of variables, and I'm going to take those out and put them out here with the x. So now on the outside, I have x, y, because I pulled out a pair of x's and I pulled out a pair of y's. And then what am I left with on the inside? The only thing I have left is one lonely little x. So the square root of x cubed y squared is simply xy times the square root of x. I know some of you are probably thinking, Mrs. Ott, it made sense with the numbers, but now you are crazy and I don't understand this. On the other hand, maybe some of you are saying, oh, that's so cool, Mrs. Ott. Yeah, I get it. Either way, we're going to work on it tomorrow and you'll end up loving it just like I do. So why don't you try this next one, x squared y cubed x squared. Pause the video, see what you can come up with, and I will show the answer in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, guys, so here I have the entire answer worked out with each of the different steps. First thing I did was break it down into its different parts. And then I pulled out, first I started with a pair of x's. Then I brought another pair of x's. Oh, you know what? Sorry, I need a multiplication sign there, don't I? Right there. Oh, that's not the color I wanted. Come on, Mrs. Ott, get your technology right. There we, nope. I'll get it one of these days. There it is. Okay. So I brought down one set of x's, and then I brought out another set of x's, leaving me x times x on the outside. And then I brought down a pair of y's. And all that was left was this lonely y right there. And on the outside, I have x times y, which can simplify even further to x squared times y. Don't panic if you're a little lost. Write the notes down, see what you can figure out. And my reflection for you today is I want you to try and simplify this problem here. It has numbers and variables, and I made it hard and potentially confusing for a purpose. I want you to struggle with this a little bit. I know that sounds mean, but I want you to struggle with it. And when you respond to the, when you turn in the assignment and leave me a response, I want you to really tell me if you're confused, what specifically is confusing you? Like, how far did you get and where did you get stuck? That's going to give me information um, for the next day's class so that I can really design our class to meet your needs. If, on the other hand, this isn't challenging at all, let me know and I'll give you a challenging one. All right, guys, do the reflection, turn it in, and I will see you in class tomorrow. Bye-bye.